Dr. Professor, I honestly don't understand that 8-step synthesis that you just wrote down, because how did that carbon chain turn into that carbon chain? Welcome to Curly Carbocation. Please subscribe and stay tuned. In organic chemistry, methyl shifts and chemical reactions were one of the more difficult things I had to deal with. Because when you look at a reaction, the reactant and the product alone look like they're not related at all. When everything gets confusing, remind yourself every single time that it's stability and electrons that you need to focus on. Unlike the acid-base reactions you're used to in general chemistry, now you have to deal with a lot of intermediates. And these intermediates, still being relatively unstable energetically wise compared to the reactant and the product, still require some sort of stability. That's where our friend methyl shift comes into play. Quick interjection, all of you artsy science people need to make pretty textbooks, because organic chemistry textbooks, especially when it comes to reactions, are really difficult to follow. So I'm gonna do my best, but I need pretty textbooks from you guys. Now back to methyl shifts. I have put a box around the same carbon so that it's easier to focus on. Here we have a secondary carbocation, and here is a tertiary carbocation. This carbon, this methyl, moved to where the secondary was. Now, how does this tie into stability? Tertiary carbocations are more stable than secondary carbocations, which are more stable than primary carbocations. To my knowledge, there are no quaternary carbocations, because that would just be a carbon with 4 bonds. This carbocation right here, the tertiary one, has 1, 2, 3 carbons that I can hold on to. This secondary carbocation has 1, 2 carbons that it's connected to. So the carbon with greater connection is able to afford less stability. If you are going through a rough time, it is easier for you to carry on in your unstable state when you've got a community around you to support you. Hey, look at that, we're carbon-based and carbon follows the same thing. So even if both of these just have 1 positive charge, having greater connection around the point of instability is a lot better than the original structure. Any of these methyls could work because they rotate around that bond, but this is just aesthetically prettier. I digress. This methyl will shift to the secondary carbocation, leaving no charge at this point. But now that that methyl has left with its electrons, this point is left with a positive charge. And this becomes a new spot for a nucleophile to attack. If this video helped you, please give me a like, and I will see you in my next video. Bye!